There she is. All right, we're here in Yakima, Washington for a tour of the Cub Crafters factory where they're producing a brand new airplane every 30 hours. They've got over 200 employees working here. We're going to start over where they, on the other side of the field where they start with the individual parts, and then we'll come through the assembly line here that's on a 30-hour roll. Every 30 hours, an aircraft is going to change stations here as a different phase of the build gets done. And this assembly line behind me, they're building FAR Part 21 certified aircraft, ASTM standard aircraft for EASA and Europe, and experimental aircraft as well. So all three different categories are getting built to the same standard because it's just easier to do it that way here at Cub Crafters. And they've been doing this since about 1980. Of course, they started with the Super Cubs, and then they came up with their own design. When was that first one, Brad? About 2006?
Super Cubs in 1996. We started building new Super Cubs on their type certificate in about that same time frame. We got our own type certificate for the Top Cub in 2006, the X Cub in 2016, the Carbon Cub started about 2009.
There you go. Let's go take a look.
Foam blocks being machined to make a new mold.
So this is a floor.
And this will be a seat base and floor in an airplane.
So this is the
size and shape.
This is the composite shop. Why they call them a carbon cub? Because a lot of the parts are made out of carbon fiber material and resin, and they start out with a mold, and then they produce the carbon part from that. See some vacuum molding going on there.
Yeah. So here's an example of a finished mold that's in process. This one hasn't been prepped to go, so this one just had a part come off of it. I can tell that by the little pieces of composite that are still there. Here is a mold in process. So this has been resin infused. The resin's infused with a vacuum. We use vacuum to try and pull as much resin back out as possible. And this is the typical wet layup carbon fiber process. So X Cub parts, Carbon Cub, FX3, Carbon Cub SS, all of those airplanes get these type of parts here. Carbon Cub UL, a little different.
Pre-preg.
We're doing pre-preg composites on that. So the composite gets laid in, it still gets held in place with vacuum, but then it goes in one of those big ovens over there, and the oven is used to heat treat, which makes the resin soft, and then once it cools down, the resin gets hard again, and you don't end up with any extra resin weight you're carrying. So for the same strength of part, it's about 30% lighter, and a little more expensive to build, but we're all about lightweight and the best in class performance here, which oftentimes means taking weight out of the airplanes.
Paying for less weight.
It looks like this, and you can see it's still got a lot of trim work to be done. But you can also feel what that weighs, which is
very light.
Little.
Yes. All these stacks of carbon fiber parts.
And then back in here, this is a negative pressure room. So here's where they're doing all the trim work, and the guys are wearing the spacesuits. And that room is always pulling air into it, so we're not getting exposed to it.
Right.
But they do all the trim work, and then once it comes out of trim, it looks like this. Now it's ready to go to the next stage, which is over here in assembly, where they would put the fasteners on. We have sheet metal parts going down this side, and we have CNC parts going down this side here.
The machine shop. Oh yeah, there goes the CNC machines right there.
So this is our biggest capital investment. There's about $15 million worth of machines in this room.
Wow.
Airplanes and experimental airplanes in the same facility, we have to build everything up to the certified standard. So part of building a certified airplane is parts traceability. So if you notice, everything's got a barcode on it. And that tells a quality inspector where we got this piece of aluminum, when we got this piece of aluminum, and from what vendor. So if there was ever down the road a problem where, you know, there was some failure because the wrong aluminum alloy was used or something like that, we could quantify which aluminum went onto which airplane, what foundry we got it from, which mill we got it from, and even where they mined the ore.
Wow.
So
that's
it's a
building
massive tracking effort. And again, because we're doing the same thing with certified airplanes and experimental airplanes, we do that for all the airplanes. So we have full parts traceability.
Got it.
But this is where parts start getting built, is with these raw materials right here.
Here's your steel tube for the fuselages, aluminum billet, and aluminum sheet. Here they're machining a piece of sheet metal here. It's not laser cut, it's a machine cut, so you don't have the problems of temperature change associated with laser cutting. It's a little slower, but a little better quality. Here's the water jet table where they can cut titanium and steel bits, whereas the aluminum bits are done with the machine cut over there. This is done with water jetting. So about 500 parts a day come out of this shop alone. The machine shop. The CNC machine working on some billet aluminum. All programmed in.
That is a aileron hanger.
Yeah.
For the wing in a carbon cover next cub, I'm not quite sure. But that starts as a single solid piece of aluminum.
Billet, yeah.
It gets cut, it gets trimmed, it gets cored out to save weight out of it. What I've been told is by weight of all the material that comes into this shop, only about 20% of the weight goes out as finished parts. The other 80% goes out as machine shaving.
Yeah, it's all, there's the rest of your weight right there. Paying for less weight.
It's also where we pre-assemble the wings as their own sub-assemblies.
The weld shop. So we got fuselages, there we go, right there, and wings right over here. Now the wings aren't welded up, but they're built up. Where all the parts start to shape up and start looking like an airplane. Here's an example of some carbon fiber in the wingtip bows. Used to be wood, making the whole structure stronger and lighter. So nowadays your steel tube and welded fuselage is done by CNC machine. All these flutes, see each individual part, and then it gets laid into the jig here where it gets welded up. Two halves, here's the other half, and then these two halves go on this jig here to be welded together as a final fuselage, like something over there. So this one jig is the mother of all carbon cubs out there today. With some minor adjustments, they can create each different model of carbon cub fuselage off of this jig. Over 800 to date. And this is the jig for the X cub. So that jig's for all the carbon cubs, this one for all the X cubs. Before the fuselage is powder coated, it's got to go through a quality inspection. Make sure it's dimensionally correct on this rotisserie. Back here we're getting some of the other steel flight controls like elevators and stabilizers. There's some of the jigs there and over here. So from here, all these sub-assemblies are going to go over to the main assembly line, which is on the other end of the airport here at Yakima. Sheet metal parts for flaps and ailerons, and get your leading edges smashed to fit right in here. Sometimes there's some scrap left over that didn't quite make the grade. Here's all the parts for the next turn in the factory. Somebody's keeping all the parts organized that need to go next for that particular build right here.
And then each airplane moves forward one station.
Every 30 hours on that clock, everything moves one station. Got it.
So right now there's 17 hours left before the turn when everything moves. And you'll see these big clocks all around the factory where everybody can see them. And that's how we keep everything synchronized.
And so we start here at Station 1 and work your way through, and I counted up to, what was there, up to 12 stations down here. So this is the final assembly line, or the actual assembly line of all the parts that we saw being made in the various machine shops.
And you saw it being built over at the other factory. Now it's been powder coated. It's come back over here, and they're gluing the composite stringers that form the outside shape of the airplane on. Composite dorsal forms the top shape of the fuselage. They're putting in the extended baggage compartment. Next they'll be putting in fuel lines and avionics and wiring harnesses. Anything that it's either more convenient for us to install without cover or has to be put in place before it gets covered goes in on these first 4 stations right here. Backup batteries in, floorboards are in, header tank for the Rotax engine, fuel systems all in, all of the composite stringers that form the shape of the airplane. Baggage compartments in, we've got rudder cables going back. This airplane is just about ready to go to cover, and it's at Station 4. So when that clock counts down to 0, 17 hours from now, all of this work needs to be done. The airplane needs to move to Station 5.
Okay, now here's the amazing part. These folks are going to get these aircraft covered, completely covered in 30 hours.
Yep.
So that clock's going to turn 30 hours, and they're going to have the entire airframe covered. And if you've ever worked with dope and fabric before, you know how long that takes.
And actually, Juan, they have to move a little faster than that, because not only do they support the production line, they're also recovering wings for our rebuild shop. They're recovering fuselages for our rebuild shop. So on average, they have to complete 1 airplane's worth of parts every 24 working hours.
Wow. Because they're also supporting the rebuild shop, which is quite busy, I'm sure.
Job title is technician, but it's more like artist.
Yes. This is the new Oratex fabric here, and Cub Crafters has come up with a really excellent application process for the Oratex to get the most professional looking finish out of an Oratex covered aircraft. So here they only glue the parts that they need gluing. Instead of slathering the glue across the entire fabric surface, they've gone ahead and marked out exactly where the tapes are going to go and the various gaskets and that sort of thing are going to go, and just glue what they need. By the way, they use pop rivets here to hold the fabric onto the wing and then tape over those rivets. To keep the UVs out.
Keeps the UV off the fabric, makes the fabric last longer. It is a polytone paint, and it has a very high silver solid content that doesn't allow UV
sunlight.
To hit the fabric. And
so
on top of that, we'll paint the customer's color, yellow, red, or whatever they want.
So this is another 30-hour station. So 30 hours to cover and then 30 hours to paint the aircraft through silver and final finish color. There they're painting some flaps or ailerons in there, and this is one of the hardest things to keep the assembly line going on a 30-day, or a 30-hour rotation, is the painting. So they come out of paint, and then you're up here to Station 7. So the aircraft's painted. Now we start installing everything that needs to go on the inside of the airplane, doors and windows. Then Station 8, landing gear and engines, and on down to Station 9, getting it prepared to put the wings on, where it's going to end up in Station 12. And here's one of the new Rotax engines right here. 916 IS for the UL Cub with the Oratex covering. Avionics in. Because of holdups in engine manufacturing, they've got to keep quite a few $1 million worth of engines in stock. They can't go as needed or when needed type of manufacturing on these engines. They got to get them here ahead of time to keep up with the 30-hour roll. So the timing is choreographed such that they build these wings several weeks into the build of the airplane itself, so that the two meet here at Station 9. A brand new X-Cub with the 390 just got the wings hung on it this morning. Moving on down here closer to Station 11 and 12, the final assembly. Here at Station 11, next to the great big hangar doors, they can begin to run up the engines. UL Cub with the new road tax 916 IS. So here they get the last details done, where the aircraft is ready finally for flight test. This is going to Embry-Riddle University. It's one of the nose gear Cubs for their precision flying team. And here's a bunch of different customer aircraft, either brand new aircraft ready to get flown out, or other aircraft getting sold, bought, sold, or worked on. What's that Husky doing there? So this is the final test flight area here. When the weather's really hot outside, these guys are here early in the morning, so they're not breaking in these brand new engines in the heat of the afternoon. They're doing it real early in the morning. And any final tiny little cosmetic touch-up bits they're taking care of here before the aircraft go to the customer. Here's a real special X-Cub being built specifically for the USDA Predator control. Here's a automatic flagger located here on the landing gear. They're going to be doing the Predator control right out of this window here. They've even got themselves a little extra armor here in case the Predator control manager gets a little out of hand. And they've moved all of the wires and other such that was normally located over here over to this side of the aircraft, so they can operate out of that window right there.
Yeah, this is actually the shooter's window specifically for this airplane. And let me open that shooter's window and show you how that works.
Yeah, let's see how that works.
He's sitting in the front seat. The gunner's going to be sitting in the back seat.
Oh, okay, it's just that much of the window opens up. Got it.
And when they're hunting predators, coyotes and wolves in the wintertime, that actually keeps everybody a lot warmer with that smaller window. And the dimensions of this window are such that it's hard for the gunner to get his line of sight back enough to shoot the lift strut. But even if he did accidentally shoot the lift strut, it has a layer of ballistic armor on it. It's a Kevlar composite piece we make specifically just for USDA. We've tested it with both shotguns with slugs and flight tested it. And so this is a fully certified setup on an X-Cub for Predator control, so that the pilot and the gunner are safe when they're doing that.
And this is nothing new. USDA's been doing this for years with a tired old fleet of Super Cubs, right?
Correct.
So this is their effort to upgrade their fleet.
Another thing, this prop is a Hartzell Trailblazer constant speed
Hey,
prop,
I got one of those.
but it's got a special part number because Hartzell paints the backside of the tips white. So again, the gunner can see the propeller arc. So he's shooting from between that lift strut and this propeller arc, and this angle right here.
Down in here.
But he needs to be able to see where that propeller is.
So if you're buying an experimental version, build-it-yourself version of the Carbon Cub, it's going to get shipped out of this room right here. So all the parts in the warehouse and bits and pieces they need are in here, and they'll gather up the engine and all the rest of it. They'll box it up here and ship it out that door there to your house so you can build your own Carbon Cub. And then you've got service after the sale here in the service center. So if you need to get your annual inspection done, or some extra avionics done, or some rebuild work after a mishap or a ground loop, you can get it all done here in a separate building here at Yakima. Thanks so much for the tour of the factory, Brad.
My pleasure.
All right.
Good having you here.
All right. See you here.